Okay, so we've written off-screen 2 Mathematica programs. We did have an off by 1 error in our program, in our product
Formula
previously. We go from 0, here we had it going from 0 to n instead of 0 to n minus 1, which was correct. But anyway, so with 10 people, when we tested this, it was about 2.4% chance of a pair is what your method was saying.
Mm-hmm.
Does that make sense?
I mean, yeah, it should be pretty low.
Okay, so why don't you try another guess, because we're trying to get up to 50.
Maybe let's try like 100 people.
Okay, with 100 people, it's
Less. That's 10 to the minus 8th.
okay.
So this doesn't make any sense.
Why?
Well, we have more people and we have less of a chance.
If we have more people.
Yeah, we should have more. So
Well-
like maybe if we go to like 10,000, like this should basically guarantee.
Well, it should guarantee because you need
What number guarantees a match?
366 people.
Mm-hmm.
Okay.
And you need 367.
So even if we, let's do 367 exactly. So we'll have a match here, but it's effectively 0.
Why? Why does it get 0 when you're having 360? Remember, the number of people here is actually n plus 1.
Mm-hmm. So we still should have a match. But
Yeah, but why? Why is it saying a 0% chance of a match?
Oh, because here we have a 0.
Yeah. Okay, so now we'll play with just a quick statistical program looking at what's going on here. I probably have too many spaces. Let me just shrink the spaces. Is this on the screen?
No, not yet.
Is it now?
Yeah.
Okay, so with 10 people, so what we're doing is we're running 10,000 trials. We always start with an empty table of 366 zeros. Every time we run a trial with n people, so this time the n is the number of people, we pick that many n random integers. We put in our table at the spot of the integer, the random integer we picked, we just increment it, so it goes from 0 to 1, representing that day has a birthday.
Yep.
And then we look at the end of picking those random numbers, in this case 10. If the maximum value of any day in that table is bigger than 1, what would that mean?
So that means at least 2 people have the same birthday.
Yep. So then we increment a counter, and at the end we just the count divided by the number of trials. So this says with 10 people and 100,000 trials, it was about an 11.55% chance of someone having a birthday.
2 people have the same birthday.
2 people having the same birthday. And if we wanted to be safe, we could run it 100,000 times. And is that still running?
Yeah.
There we go, 11.45. So 10,000 probably is enough.
Yeah.
Okay, so what number do you want to try next?
Let's,
You drew 50.
yeah.
50 people.
All right, so what do you expect here? With 50 people, what do you expect the chances of a match is?
Well, it's 50. Basically, it's.
So it was a 10.
It's like about a 1/7, like 1/7 of the total number of possible birthdays. So maybe around 1/7.
Okay, which is what? Do you know what 1/7 is as a percent?
14%, I think.
Okay, 14%.
I mean, we had around 10% for 10 people.
Uh-huh.
So
So
maybe
maybe
we
it should
could say it's
more.
around 50.
Okay, all right, so let's see.
We get
It's
almost,
basically guaranteed.
So 97% chance. So in other words, if you had 50 people in a room, it would be pretty surprising, actually,
If you didn't.
if
have
2
the same
people didn't
birthday.
have the same birthday. Okay, but does that surprise you?
That's
Yes.
pretty surprising.
Okay. All right, so we got to go lower.
So maybe let's try like 25.
I'll let the cat.
So 25 gives us 57%, which
So we're
is
pretty close.
still too high.
So we have to go down maybe to like.
Let's try 20. 20 is 40%.
So we
So
have to go up maybe to 20, 21. 43. Keep going up by.
so 48.
So maybe 23 people. Yeah,
So
23 people.
23 people, so you have about 50%.
All right, so let's run that 100,000 times just so we can be somewhat sure. So there we go. With 100,000 runs, it turns out to be 23 people. Okay. So what does that say about your English class?
So that
You
we have 22 or 24.
24.
So
At least according to your teacher, you have 24.
So it's still a little surprising that 2 people would have the same birthday, but not all that
50%.
surprising. But I guess
It's about a 54% chance with 24 people.
so it's not too surprising, but having 3 pairs is a little more
quite
surprising.
surprising. Yeah.
Yeah, okay. So we probably won't get to the 3 pairs today, but let's see if we can understand this surprise, that it only takes 23 people to have a match.
Okay.